Hi guys, this is the video for Chapter 8, Lesson 4. So a lot of you guys who are in class have already gone over this lesson, so some of this will be a review for you. But what we're taking a look at today is trigonometry. And so if you think of the word trigon, that means triangle. Metry is means the measure of. So when we put this together, really it's the measure of triangles. And so trigonometry really studies the ratios and measurements and parts of triangles, and so specifically right triangles. And so the big thing you want to kind of take note of is there are three functions when it comes to trigonometry. There's sine, cosine, and tangent. Okay, so these are the shortened version of them. And so what these represent, these describe the ratio of certain parts of a triangle in relation to each other, okay? So we have an acronym to help us remember those parts and those ratios, and it's SO, CA, TOA, TOA, TOA. So knowing this acronym is going to be huge in helping you remember the ratio. So for sine, really what that means is you have sine of an angle equals opposite over hypotenuse. Cosine of an angle equals adjacent over hypotenuse. And then tangent of an angle equals opposite over adjacent. So let's use this little triangle to help us do a little example here. So let's say I've got a little right triangle, and this is my right angle. I'm going to name this angle A, B, C, and these sides will be, let's say 4, 5, 6. Okay, so I'm going to just give them a length. It's 4, 5, and 6. So if I were looking for the ratios of sine of angle B, so for example, if I was looking at sine of angle B, that means B is the perspective I'm looking out of, and I'm going to relate the sides to angle B. So opposite of angle B is this side here, which is 6, and the hypotenuse of this triangle is 5. Now, actually, I probably should switch these two because the hypotenuse is usually the longest. So let me switch that so it makes a little more sense for us so we're not confused. And you can tell which one the hypotenuse is first by looking at which one's the longest side, and then also by looking at what is across from the right angle. So see how 6 here, BC, is across from the right angle, which is angle A. And so 6 is the hypotenuse. So this would be 5 over 6. Sine of B equals 5 over 6. Let's try sine of C. So sine of angle C, opposite of angle C is 4, and the hypotenuse is 6, so it's 4 over 6. And then you can write this also as a decimal if needed, okay? So cosine, that's adjacent over hypotenuse. So to distinguish between what's adjacent, what's hypotenuse, you're really going to look at the sides touching your angle. So if I were to say cosine of angle B, well, both 4 and 6 are adjacent to angle B. However, one of them is the hypotenuse, and that doesn't change. So see how 6 is going to be the hypotenuse? That means 4 is adjacent. 4 over 6. And then we have cosine of angle C, and that would be 5 over 6 because we are looking for the ratios of adjacent over hypotenuse, 5 over 6. Okay. Now, tangent, we could do tangent of angle B, tangent of angle C, and try those out. So write our ratios out. Opposite of B is 5. Adjacent to B is 4, so 5 over 4. Opposite of opposite of angle C is 4, and what's adjacent to it is 5. Okay. So now if I wanted to solve for these angles, I can do that. So let's talk about how I would solve for these angles using my trig functions. Now the purpose of the trig functions isn't just to write ratios. The ratios actually, with the trig functions, help you solve and find a missing part. So really that is the reason we are learning these trig functions, is because there are times when maybe you can't do the Pythagorean theorem, or you don't have a special right triangle to work with, and you're given some information, but not enough that you can use those other formats that we've learned in the past to solve for your missing sides or your missing angles. So we can now use a new format to find that. So if I were to solve for, let's say I'm going to solve for these few problems on the bottom. We'll do sine, cosine, tangent, okay? How would we find the actual angle that we're missing? Because this says angle B, right, and angle C and angle C there. So first of all, you get your right, so you have to be careful sometimes with the format of your calculator. I don't have this quite figured out, but if you're plugging this in, you're looking for a decimal and you get like a weird, like if you're plugging this in and you're looking for a degree of something and you get a decimal, then that would be a red flag, because you're normally gonna get degrees that are in numbers that are in bigger than at least probably 10, right? So when I plugged this in, I plugged in the inverse of sine times 4/6, and then when I pressed entered, I have 41.8, and that's my answer. So that's a side. So your homework is going to be a little Valentine's activity. And really what you're doing here is, I'll show you kind of what your homework looks like. It's a coloring activity. You're going to work this out. Your answers are on the bottom. And whatever your answers are, that's the color you're going to color that number in, okay? So for example, let's do number 1. And I'll talk to you about how to find the missing side using the angle, okay? So looking at the angle, our perspective is always starting at the angle given to us or the one that we're trying to find. So we're gonna look at, out of 29, what is the relationship of x and 13 to 29? So 13 is the hypotenuse and x is adjacent. So if I look at this, I have AH, and I'm gonna spell out my acronym, so, ka, toa. So which acronym here spells out AH? Right here, right? Ka. So this would be the cosine of 29 equals x over 13. And so because I'm looking for x, I'm going to multiply by 13 on both sides. And so when I plug this in my calculator, I'm going to plug in cosine of 29 times 13. So I'm going to get my calculator out here, plug in cosine of 29. And you're not doing the inverse, you're just multiplying that out. So I get like 0.8746, something like that, times 13. And when I multiply that out, I get 11.37 as my answer. So when I round it to the nearest tenth, this is 11.4. So when I look down here, 11.4 is light blue. And I can cross that off, I guess. So that means number 1 is light blue. So on my coloring page, which is going to be here, anywhere I see the number 1, I would color light blue. So anywhere I see, it's kind of like a color by number here, right? Anywhere I see number 1, I'm going to color light blue. Let's try number 2. So looking out from 63, my perspective is 63. 18 would be opposite, and x would be the hypotenuse. So OH, that spells out so, which is sine. So I'm going to write this as sine of 68 equals 18 over x. Okay, notice how this one is different from the other one where my unknown is on the bottom this time, whereas previously my unknown was in the numerator. So when I'm working this out, denominator this time, whereas my previous problem, x was in the numerator. So when I'm working this out, if I'm really to get x by itself, well, x is the denominator. So if I get rid of 18, I still have a fraction 1 over x. And I want x as a whole number. So I'm going to multiply both sides by x. And I have sine times 68 times x. And so I'll rewrite that out here. Equals 18. And now to get x by itself, I'm going to divide by sine over 68. So when I divide by sine times 68, then I get x by itself, and that becomes my answer. So 18 divided by sine of 68. Okay, when I plug that in, I get like 19.41. So if I look down, 19.4, where do I have that? Do I have that anywhere? Doesn't look like it. So if nothing matches, I probably want to go back up and take a look. Okay, so this is a great example where I did something wrong. I didn't get the right answer, and I'm like, what's going on? Why did I not get the right answer? Well, it's because I put in 68 instead of 63. Maybe you noticed that already, but that's 63. And so when I plug it in and actually work it out, x equals 20.2. So now I'm going to go down, look for 20.2. That's purple. Okay, so number 2, anywhere I see the number 2 is purple. And how ironic, I'm using a purple pen. Purple. Okay, so that's how you're going to do it. These 2 examples, the way you're working it out looks a little bit different because one of them, the unknown, is the numerator. So all you have to do is multiply by the denominator to get x by itself. Whereas when x is the denominator, you need to multiply both sides and then divide by what's not x, okay? And so that's why the way you work it out is a little bit different. Okay, so that is basically today's lesson, is just to review and figure out how to find missing parts, and that's it.